All right. Okay, switching back to English. Good morning, everybody, and welcome to the first online school on smart data processing and systems of deep insight, which is organized in the context of the Destini Horizon 2020 training project. My name is Andreas Andreou, and I act as the coordinator of the Destini project. Before explaining what the term smart data is, I would like to make a short presentation to our project, and later on I will put all the pieces of the puzzle in place. So my presentation today is, the outline of this presentation is as follows. First, I will briefly introduce the Destini project, some facts and data and information. Then I will move forward to presenting very quickly the concept and the approach of this project. And I will concentrate more on the indicative areas of applied research we have identified so far. Next, I will move on presenting some case studies and applications, some words on dissemination and communication activities, and then I will close the presentation with some concluding remarks and some information about the school. So, what is Destini? Destini is a twinning project, a CSA action with a budget of approximately 800,000 euros. The duration is 3 years. So the project started in October 2019 and will be completed by the end of September 2022. The coordinator is the Cyprus University of Technology, and on board with us we have two very well-known and leading universities, the University of Tilburg and the associated Hieronymus Academy of Data Science from the Netherlands, and Sapienza Università di Roma, the University of Rome, Sapienza from Italy. Now, the vision of the project is to become a leverage for our group, for our university, to become a global leader in the research area of smart data processing and systems of deep insight. In this context, we aspire to deliver world-class scientific excellence, innovation of global outreach, but at the same time to offer practical benefits to our local economy, to the broader European economy, industry, market, and society. We have three distinct objectives. First, we need to define a clear research vision, a perspective, to develop a common research strategy and agenda amongst the partners so as to be able to create new scientific knowledge or exchange existing scientific knowledge and research practices, mostly from the leading universities, the two partners from Italy and the Netherlands, towards CUT, on a set of research topics of interest, of mutual interest. Our second objective is to create joint programs for training and education, as well as mobility. These programs target early stage researchers, as well as PhD candidates, master students, and of course, industrial and market players. For the latter, we give great emphasis on forming a strong collaboration basis, which will include key strategic partners, stakeholders, and other industrial and market players, which will enable us to experiment with real-world problems and real-world data. How is this vision of Destini going to be realized? On top, we have, on the left side, we have the two leading universities. On top, we have the Tilburg University and the Hieronymus Academy of Data Science, which is led by professors Mike Papazoglou and Willem-Jan van de Heuvel, and the Sapienza University of Rome, led by professors Mario Lenzerini and Massimo Messella. These two leading universities will transfer scientific knowledge, research expertise, and best research practices to our group. And this will be facilitated through the exchange of personnel, by performing expert visits and site visits, by organizing joint events such as workshops or schools like the one we are launching today, by delivering special purpose or general purpose lectures, seminars, and talks, developing mobility and joint programs, and of course, the participation in scientific conferences and workshops. Now, coming to a brief overview of the concept and the approach of the project. Destini revolves around three main joint research areas. The first one is called Smart Data Processing Systems. The second one is Systems of Deep Insight. And the third one is a methodology for developing smart data-centric services and applications. Destini essentially follows a virtuous circle of research where each different area, each distinct area is feeding and is being fed by the results of the other two. And all these are intertwined and integrated with a dedicated framework for applied research, which comprises strategic partners and stakeholders. These partners are engaged and are trained to support the development, the identification and development of pilots that come from a wide range of applications that fall within the smart specialization strategy of Cyprus. To name a few, smart and sustainable tourism, green shipping, smart healthcare, and smart food industry. Very few words just to mention the joint research areas of interest. The first one is called, as I said before, Smart Data Processing Systems. It is divided into two sub-areas. The first one is about developing smart integrative solutions, and the second one is about developing formal models that will allow us to design smart data processing systems and applications. The second joint research area is called Systems of Deep Insight. Within this area, we find three subcategories. The first one is the development of a cross-functional and integrated analytics vision. The second one is devoted to developing adaptive and self-service smart data platforms. And the third one is an implementation of an insights to execution process that essentially turns data into actions. And the third one is a methodology for developing smart data-centric services and applications, which is also divided into two sub-areas. The first one is the methodology per se, while the second one is the development of a domain-specific language, which will allow us to design and specify smart data-centric services and applications. So the consortium of Destini conducts research and investigates topics, problems, challenges within these three research areas of interest. This is done with the support of a research and innovation agenda, which we have developed in order to guide us how to proceed with our research activities. And this whole approach is depicted in this figure here, where we can see the three joint research areas of interest at the lower part, coupled with some transversal topics like Internet of Things and digital, the very important technology of digital twins. I will refer to this technology later on. And this gives birth to setting up pilots belonging to different application domains. For example, we have the smart healthcare application domain and the smart manufacturing. And how all this is combined together, we can see on the left part a group of sensors providing sensing capabilities, gathering data. These data are communicated, are aggregated. They form a knowledge base here, which constitutes the basis for smart processing to take place. Eventually, this smart processing leads to informed decisions and supports decision-making at this stage here. Destini gives great emphasis on team building and engaging stakeholders, as I said before. To this end, we have formed an advisory board, and we have invited some significant bodies, organizations, and companies to take part in this advisory board. The purpose of this advisory board is to offer expertise and direct our research efforts towards specific industrial verticals. For example, we have the Cypriot Ministry of Industry, Commerce, Energy and Tourism to advise us on the two major sectors in Cyprus, which is industry, not so much big in terms of volume, but quite significant for our economy, and of course, tourism, mostly on policy making. We have Hellenic Bank directing our research efforts on the financial sector, the Water Board of Lemesos advising us on critical public infrastructures and more specifically on water supply networks. We have the Paradisodis Group, a major industrial player in Cyprus, which is involved with poultry meat production. Limassol municipality with many experiences in projects revolving around smart cities. We have Unity Marine, a major shipping company in Cyprus with worldwide presence. And last but not least, the Cyprus Institute of Neurology and Genetics, which will advise us on health pilots. So far, our network of collaborators includes two centers of excellence in Cyprus, two funded teaming phase 2 projects. The first one is the Destini Center of Excellence, the Excelsior, which is executed here at CUT and is emphasizing on Earth data, observation, space technology, and the like. The second one is coordinated by UCY, by the University of Cyprus. It is the CYENS Center of Excellence, formerly known as RISE. This Center of Excellence focuses on interactive media, smart systems, and emerging technology. And two very important initiatives and projects belonging to the digital cultural heritage domain, which is the Mnemosyne Era Chair and the UNESCO Chair. Both have been awarded to a friend and colleague of mine, Professor Marinos Ioannidis, here at our department. I should also mention that the project is fully aligned as a project, as the call dictates, with the smart specialization strategy of Cyprus. This strategy has identified information communication technology to be a critical sector, having a horizontal character, a critical sector of major importance to our economy, and of course, the generation of new jobs. In this respect, we direct our research efforts toward an applied research framework that comprises specific priority sectors which have a common characteristic. They produce high volumes of data and are in great need for decision support. These priority sectors are transportation, agriculture and food industry, health, and tourism. You can see in the parentheses some indicative challenges or sub-areas of interest, while in square brackets in red fonts, you can see the members of the advisory board that will guide us and will provide consulting and expertise towards these priority sectors. Last is the involvement of early stage researchers. This is quite important for our project. We have developed a dedicated mobility program in order to attract high quality early stage researchers. that will be able to relocate in Cyprus for a period between 1 to 3 months, and will join our group and will perform research, will investigate research topics with us. These early stage researchers will be supported financially for their relocation and will enjoy a salary of 2,000 euros per month. What is an early stage researcher? According to EU, an ESR at the time of the recruitment is a person which is at the first 4 years of their research careers, but they have not been yet awarded a doctoral degree. Now, coming to some indicative areas of applied research. So far, we have identified quite a few research areas with practical value, such as smart data processing in general, the digital twins technology, business process mining, ambient intelligence, and blockchain integration, and the list goes on and on. As the project evolves, it is enriched. So I will briefly present each of these areas and try to give a connection with Destini, how Destini plans to address certain challenges within each of these research areas. Smart data processing. First of all, we have to define what we mean by the term smart. This term is basically used to emphasize the latent value that is inherent in widely dispersed and unconnected data sources. So the criterion here is to characterize something as smart is not the volume of the data that is available, but the smart content techniques that enables us to collect and accumulate the data, but also to be able to understand their context and meaning. The latter, of course, requires a special category of systems, which we call systems of deep insight. The purpose of this systems is to discover hidden associations between the data, to prioritize the results, to locate, to discover large-scale patterns, trends, or other useful insights that will enable us at the end of the day to react to this piece of information that is revealed to us. Now, the digital twins essentially is a technology that enables us to create virtual replicas of physical devices. We need these virtual replicas as computer or data scientists. We need these replicas to run simulations before we actually build or deploy these physical devices. So it enables us to study behavior, to study parameters, to modify the parameters at a controlled level so that we are more make some decisions, having more information in hand before launching the physical devices or before interfering with the actual production. So our intention here is to be able to deliver experimentable and interactive digital twins that will have some sort of smartness, will be graphical environments, interactive graphical environments that will enable us to experiment either at the level of presenting the information at the graphical level or at the level of within the digital twin be able to perform some sort of smart activities such as predicting and directing future maintenance, for example, of machinery in a smart factory. Business process mining is essentially an analytical approach. This approach enables us to monitor, discover business process, and at the end of the day, try to improve them. How do we do that? We are based on the processing of event logs, series of data that come from a company's information system. For example, an enterprise resource planning system or a customer relationship management system. We get this data and essentially we assess how the business processes actually behave, not what the company wishes these processes to behave, so as to identify possible areas to improve these processes at the operational level. So business process mining is fact-based, it is objective, non-invasive, and it reveals hidden problems and gives us objective insights in order to act for optimizing these business processes. So our goal is to perform smart data processing and process mining in order to turn this event data we collect into insights and into actions. And we plan to do this developing applications in the context of Industry 4.0 or smart manufacturing, or, for example, evolving a dedicated business process to achieve a predefined goal, that is optimization, or checking conformance to standards of a business process through process mining. Ambient intelligence now is a term that refers to a digital environment which is responsive to the people connected to you or the things connected to you in the proximity of your surroundings. Now, this type of environment is sensitive, is adaptive, is responsive to our needs, and it was first introduced as a concept by Philips Research in 1998. This is a typical context of ambient intelligence environment. This is a home environment where we can observe different types of sensors, measuring or collecting data about different things, for example, about temperature, about light, home automation, even supporting healthcare provision with medication or location of elderly people through GPS receivers. What we plan to do is the following. We have our Dutch partner, the University of Tilburg, having a long collaboration with the originator of this term, Philips. We have our Italian friends exhibiting rich experience in ambient intelligence. So our goal as a project is to be able to improve the performance of existing ambient intelligence models by introducing new approaches, new innovative models based on artificial intelligence and machine learning for experimentation, for specification of ambient intelligent environments, and the like. Finally, blockchain integration. Blockchain is essentially a continuously growing list of records. These records are linked together, are chained together to form a series of blocks. These blocks basically include transactions. A transaction is added to a block and it is validated by multiple computers on the internet. So it is very difficult, if not impossible, for someone to breach such a security. The blockchain is readable on a public ledger, on a distributed ledger, and of course, cryptography is used to hash and secure the transactions. Well-known examples of blockchain integration or blockchain applications or technology provision is, for example, at the end of applications, the Bitcoin cryptocurrency, while at the level of technology provision, IBM has spent a lot of money recently to develop the infrastructure to support distributed ledgers. What we are trying to do with this technology is to be able to apply it in a number of different cases. For example, to integrate the blockchain with business process mining or Internet of Things or smart manufacturing. Basically, what we are going to do is to record data, either sensor data or actions or processes on a blockchain network, and then be able to keep track of sharing objects, sharing documents, or for transparency purpose, make actions that are taking place at the shop floor of a smart factory visible to everyone. Now, moving to some case studies and applications. First of all, I would like to present the Visor project, which is a project that was executed at JRAs, one of our partners, and it was about improving public order and safety in major public events. Public order is generally guaranteed by the organizers, by the police, by the organizers, by the fire brigade, and so on. They utilize a range of instruments from drawing scenarios to crowd management in order to analyze foreseen and unforeseen threats. So the idea of the Visor project was to utilize smart data collection and processing, mostly in terms of images captured through smart glasses or videos captured through drones. And then these images or videos are transmitted into a control room where people are sitting there and trying to detect unwanted events such as theft, fire, riots, and so on. I will show you a short video of about 2 minutes just to give you an idea. It's a video that JRAs has prepared for the Visor project. And I can see my friend Damian has joined in, so he will recognize the video.
Yes, I remember this video, Andreas.
Data engineering and director.
And there's our supreme leader.
Yeah.
It's a collaboration between Tilburg University and the Technical University of Eindhoven. So currently we are at the passport premises where we are currently conducting various very exciting experiments revolving around the application of data science for improving safety at smart events.
This is a huge event, as Willem-Jan said to me 2 years ago. It's an event attracting nearly 50,000 people each year.
Wij werken heel graag mee aan dergelijke experimenten. Vooral omdat we zelf medewijzer worden, maar ook omdat we het leuk vinden om te faciliteren. Maar zoals ik het zie is het een experiment. Maar als iets uitkomt waar paspoort voordeel bij heeft in het crowdcontrol, dan omarmen we dat graag.
Wij hebben een hartstikke mooi evenement. Er gebeurt hier zo ontzettend veel. En het kan een proeftuin zijn voor heel veel experimenten.
So this is one event that is traced by smart glasses.
So what we're trying to do is we're trying to exploit data, all types of data, so video data, stemming
This
from
is a
drones,
drone
for
capturing
example,
images.
and also smart glasses. We're collecting all this data to improve the safety, so people can really enjoy, let's say, the festival much better and don't need to bother too much about safety at the event.
And all these data are transmitted in the control room, and people there are analyzing the data in order to detect unwanted or undesired effects. So I don't want to play all the video because we don't have the time. So our intention in the context of Destini is to extend and enhance this project. We have been collaborating with Willem-Jan for creating a platform and an application which will automatically analyze these images and videos coming from the smart glasses and the drones, and automatically identify crime like theft or fire or unwanted social behavior and so on. And this is one of the topics that will be presented during this school. Another topic that also will be presented later today is the development of smart digital twin for hospital administration. Here we provide the realistic graphical environment of a hospital, which provides the ability for the administrators of this hospital to visualize data such as space, different types of room, pathology rooms, ICUs, operating rooms, and so on, as well as equipment, occupancy by patients, their medical record, and so on. Our intention here is to provide these administrators of the hospital the ability to test some strategic plans without risk before they are applying some decision making, for example, for rearranging space or rooms for developing new ICUs or secure areas for entering or exiting specific areas in the hospital for COVID-19 patients, and so on. So we can see on the left-hand side the top view of the hospital with the equipment, the beds, the patients, and the administrator is able to transform this scene here to add or delete equipment, form new room, change the way a room is used, and then be able to navigate through 3D, walk around this new setup, this new environment, and test this new policy and this new arrangement firsthand. The second application is again a smart digital twin, but this time for a digital health record. What essentially does is to visualize patient medical record and offer the ability to doctors not just to see a medical record in a more playful and nice way, graphical way, but also to support them to avoid prescribing contradicting drugs according to a former case or a former disease of a patient. Again, this will also be presented later today by both smart digital twins are being developed by undergraduate students as part of their thesis here at our department. The last application is about the utilization of smart data processing for detecting water leakages in water supply network. What we do here is to install noise sensors in selected positions across the network. These noise sensors produce data, noise data. These data are captured, and then we use a mathematical model to detect the possible leakage, to estimate the location of the leakage and the magnitude, and to graphically depict it on a geographical information system. Also, we plan to perform historical leakage data analysis and correlation with the type of the pipes, the age, the diameter, and correlate leakages with the type of the network in hand. This will enable predictive and preventive maintenance activities to take place. All this system is currently being supported by a digital twin application. This application is in the form of an augmented reality mobile application. And this application is utilized by the maintenance crew. Essentially, the leakage is underground, so the superintendent utilizes his mobile phone, points, directs to the point of excavation, and then the networks of other services are graphically depicted on top of this image, and also the depth of these other networks is also available in the system, so that excavations and maintenance works do not affect and do not cause damages to other networks in the area. A few words about dissemination and communication of the project. Our targeted group of stakeholders is, of course, the IT industry, but also we would like to have with us companies, businesses, and industry verticals, such as the ones I referred to earlier, shipping, finance, tourism, and so on. Of course, the research community, universities, research organizations, and institutes, and also local authorities, governmental and semi-governmental bodies, and policy makers. Our target is to assist these organizations to identify areas for innovation in terms of new products, new processes, new services, We would like, through our applied research, to support them, to offer to their clients faster and more efficient services, and in general, to enjoy the benefits that smart data processing may bring. This in turn will help these organizations to improve their customers' engagement and their productivity. This is the academic research network of our project so far. We can see major players in the European region, universities and research organizations. And also we have a rich industrial and market stakeholders list. These are companies and organizations in Cyprus. And of course, we continuously welcome new market and industrial players to our group of stakeholders. Some closing remarks. We believe that smart data systems is the future. We see this everywhere. We have smart homes, smart healthcare, smart energy, smart retail, smart everything. This is one of the reasons we decided to get involved with this area, and of course to launch the first online school on smart data processing and systems of deep insight. The target of this school is essentially to bring together students, researchers, businesses, public organizations, and of course the general public, and be able to share knowledge and experiences and applications on smart data. The school lasts for 5 days. This is the first day today, and the school ends on Friday the 16th. We have morning sessions starting 9 o'clock Cyprus time and ends at 12:30. These morning sessions are organized into 2 categories. The first 3 days are devoted to delivering general purpose talks, presenting other significant European projects, applications, case studies, and the like, while the last 2 days of the school are more concentrated on dedicated research-oriented topics, again, of an applied nature. In total, more than 30 talks will be delivered. We have speakers coming from the Cyprus University of Technology, our partners from the Netherlands, JRAs, and the University of Rome, the University of Cyprus. We have speakers from the Cyprus Institute of Neurology and Genetics, the Cyprus Telecommunication Authority, the Water Board of Lemesos. The school is broadcasted and will be broadcasted live from Facebook in this URL, and also it will be uploaded on our dedicated YouTube channel for later viewing if someone desires to see something he missed or she missed. That is all from my part. Thank you all, and I wish you all fruitful and to enjoy the very interesting talks that will be presented in this school. Is there any question from the audience, any clarification, any comments, something you would like to share with us? I think we do not have much time, but if someone wishes to make 1 or 2 short questions, I will be happy to answer them. No? Okay. At this point, I would like to call my friend and colleague, Professor Damian Tambouri from the Hieronymus Academy of Data Science, to present a project they have been executing recently, the Sodalite project. So Damian, the floor is yours. You can share your screen directly. If you would like to open your camera as well to let people know what you look like.
Yeah, so give me a second here. As a matter of fact, I think there's been a small hiccup because I will be presenting projects. So that's me. Hey, hi. That's me. I think some of you already know my face. Can you also see my screen by any chance?
Yes, yes. Can you put it in?
Yeah, I will put it in present mode in a second.
Okay, so you are not presenting the Sodalite project.
It will be the project Radon, because then Indica will present project Sodalite.
Okay.
In a few days, I think. I want to say it's either Wednesday or Thursday, I think.
Okay.
On the other hand, I chose to present Radon because my presentation is also functional for you to understand a bit better and a few more on his presentation, because his presentation is a bit more technical. I spent some extra time giving also some introductory concepts, because I'm not sure everybody in the room knows about machine learning operations as well as hybrid computing and things like that. So, well, good morning, everyone. This is Damien. Now, the project I will be talking to you about deals with serverless computing. Now, serverless computing is the next generation of microservices computing, which is one type of architecting approach to cloud computing architectures. Now, we in YATS have been trying to contextualize serverless computing and machine learning operations in the scope of a European project called Radon, which is also something that I will tell you about in a few slides, but also how to use these concepts in the scope of our action within Destini. So here's a bit of a roadmap for today. I will first like to tell you just a little bit more about YATS and Jade Lab. That's the lab where we dwell from. I'm the executive PI of Jade Lab. And I think you might have already known Willem-Jan van den Heuvel, who's the principal investigator of the lab. In any case, I will also walk you through a bunch of basic definitions, terms and concepts on MLOps and serverless computing, as well as function as a service. And then I will delve into what I mean with Radon for machine learning operations. Now, first off, a few facts about YATS. YATS is a joint institute between Tilburg University and Eindhoven University of Technology. It is, in fact, an applied data science and data engineering institute. So we work massively with industries all over the world, but also and especially in the geographical location area or region where YATS is incepted, so North Brabant in the Netherlands. And it has seen growth on every front. So our student numbers increased by around, well, 250% was true a couple years ago, 2-3 years ago. That same number, I'm afraid, is no longer true because of COVID or whatever other factors, but that same number is increasing about 100 to 150% every semester, because we have 2 intake periods. Now, in the scope of YATS, with the 300 plus student population, plus 6 applied research labs, and around 200 corporate collaboration participants in our ecosystem, Jade Lab is responsible for, let's say, the applied data science, applied data engineering research. And the research profile thereof includes, for example, concepts like DevOps and DataOps. So the operations around large-scale cloud compute applications, as well as data-intensive applications, as well as software-defined anything. So software-defined networks, software-defined systems, software-defined factories, software-defined infrastructure, and of course, applied data engineering and applied machine learning and deep learning. Deep learning is just a family of techniques inside machine learning with a slightly different flavor, as I'm sure Andreas has introduced previously. Now, in the scope of Jade Lab, we have a bunch of results. Let me not spend too much time on the results. I also, however, want to stress that one of our core tenets of our mission is to turn data into value, into tangible manifestations that industry can use to actually deliver added value to their clients, to their stakeholders, to their shareholders, and so on and so forth. Now, two of the projects within which we have been involved in the last few years and days, in fact, as well, reflect, on the one hand, large-scale cloud applications telemetry and how to use that telemetry to orchestrate a complex cloud application across high-performance compute solutions as well. That's Project Sodalite. You will know a bit more about that on Thursday. And in the scope of serverless computing. That's what I will tell you about today. Now, the key goal of the project is to deliver high quality applications in the scope of these scenarios. Our objective as a unit in the scope of these projects is to carry out predictive maintenance and application defect failure analysis in the scope of these complex cloud application scenarios. Now, in terms of Radon, the Radon Consortium was incepted in 2018. And it was incepted as a 30-month project, reasonably small project, you might say, because it's only 8 organizations. It's not too much, but the value proposition is to offer a DevOps framework for serverless and function as a service applications. Now, what do we mean with that? A DevOps, as you might know, is a set of practices, a series of tangible approaches to concrete problems in large-scale cloud applications development and operation. Now, these practices comprise all sorts of devices, all sorts of tools. Some of these tools, for example, accelerate the re-release, the use of continuous integration, the use of continuous deployment technologies, or also organizational practices like blending together development people and operations people into the same team so that they speak the same language, use the same technologies, share the same floor even. So force them to work together a bit more. Now, in the scope of DevOps, what we want to do is focus a bit more on data ops. So all sorts of operational capacity acceleration practices for big data applications. Big data applications are essentially applications that comprise all sorts of data intensive middleware and components like NoSQL databases or data lakes thereof, all sorts of data compute platforms like Apache Spark or Hadoop or whatever. And in the scope of these data ops solutions, for example, focusing on Lambda architectures, so architectures that include both brokers for data intensive computing, so brokers that capture all sorts of data sources input and broker those inputs towards all sorts of data compute platforms like stream processors as opposed to compliance checkers and so on. So you take these, for example, Lambda architecture, and you blend them with machine learning operations components. So components like PyTorch, Theano, Keras, TensorFlow, or TensorFlow Mobile, what have you. All of these components now reflect machine learning operations. So anything that you need to continuously deploy, continuously integrate machine learning solutions, or even enact more complex instances such as active learning. So active learning is the process of operators to be presented with predictions that might or might not be accurate enough, and he or she has the opportunity to correct the prediction. So interacting with the model by incepting an additional continuous redeployment of that same model, or even instances more advanced such as auto machine learning. So machine learning which learns from context the way in which it is supposed to be carried out or redeployed as well. Now, imagine in the scope of these such applications, you want to adopt one of the key architectural tenets that has been emerging in the last few years, namely serverless computing. Serverless computing essentially means that you have all of these components and you no longer care about where those components are deployed. You forget about server-side maintenance and operational capacity. That is serverless computing. Now, if you place it in context, currently we have been working with microservices. So you take all of those components that we have seen a few slides back, and essentially you containerize them and you package them and you deploy them individually as containers, regardless of the technology that you need, the stack that you need inside those containers. They can be instantiated more or less depending on what kind of traffic you might desire, what kind of load you need to address. In that context, however, it is you, the application developer and operator, that need to take care of microservice operations themselves. In the scope of functions, you turn those containers into functions that you can deploy yourself and forget about their operations, right? Of course, you would never deploy entire containers or entire microservices as single functions, because a function itself is supposed to be a fine-grained function hosted in the cloud and fully managed by the provider. So a single function could be, for example, the re-triggering of the redeployment of a model, or the data processing that you'd need to get that model into operation, or the active learning function. That can be its own function. However, this function might also demand the existence of things like AVS Lambda, components like Amazon Kinesis, or what have you. All sorts of databases, technologies, for example, that might be feasible to be worked on in this particular type of architecting scenario. Now, what are the benefits of function as a service? There's many. However, a lot of these are not proven. And Radon is also about proving those benefits to you, and also about you proving those benefits to others, of course. This is also something that you might be interested in doing in the scope of Destini, for example, with a thesis or whatever. However, what is interesting to us is that the rise of serverless has seen a massive momentum with a massive augmentation of interest by 20% monthly last year alone. So this to us says that there is a massive increase in interest. Let me give you an example of what you could do with a serverless application. So what would you do as a serverless designer or architect? So suppose you want to develop an application using Amazon Web Services. What you do is you make an account on Amazon Lambda, so AVS Lambda. What you will do is code your application, for example, using Node.js or Python or Java or whatever. You might also use whatever existing libraries. You just upload your function. You configure specific triggers that you have to develop as well. And those triggers might be, hey, there is a message that's been received by the retraining function. If that retraining message is received, then you activate this function. This is a trigger. An API gateway will take that event as a trigger, and AVS Lambda will activate the function for you. You will be billed for compute cycles. So function runtime, no longer the operation of the function in standby will be paid. This is already some extra savings, right? Now, you can imagine that this might be very much feasible to you as an early start developer, but keep in mind that this sort of technology that we are talking about exists and has been incepted in the scope of large extract, transform, and load data pipelines. So data pipelines that take the raw data, transform it into some form, save it into data at rest backgrounds, and then place it into a data in motion store, or even filter it through middleware that transform the data additionally for machine learning processing and operations, like TensorFlow, for example, and then apply additional quote unquote magic to the data. Now, what I want you to imagine is take these sorts of pipelines and then reach up to the scale in which serverless computing actually makes sense. What is that scale? That scale is things like Twitter, YouTube, you have Google Images. Just take a guess. What is the scale of types and numbers of functions that are entailed at that level? I will give you 3 seconds. If anybody speaks up and tells me a scale, actually 5 seconds. 1, 2, 3, 4, 5. The scale is from hundreds to thousands of functions running concurrently with thousands to tens of thousands of events, possible event triggers. Now, you take this large scale application, you want to do fine-grained event management. That's the only way in which Twitter survives. You want to deal with continuous and unpredictable loads. That is also what is extremely typical with things like Facebook or YouTube or whatever. And also you need to apply continuous changes to your own machine learning after extract, transform, load, right? So every cycle of extract, transform, load likely yields additional information that you have to use in the scope of your own data intensive compute pipeline. And this is exactly where Radon comes in. What you need at that stage is most likely an integrated development environment with a full stack end-to-end DevOps support, right? So you want to use this IDE with multiple teams working concurrently on different functions upon the same shared code base, but you also want them to work in a platform agnostic application and machine learning modeling and operations. For example, you might not necessarily want to use TensorFlow. You might want to use Keras as well as TensorFlow for specific other functions. And you want to do this in the same technical space because these same people will be working on the same application. Furthermore, you might want to use a policy-based end-to-end quality assurance, as well as all sorts of cost effectiveness evaluation. Now, Radon designs tools for these specific scenarios. The 4 bullet points that you have seen here are part of the Radon value proposition. And what we are apt to doing is taking these value propositions and offering concrete tools to address them. For example, with respect to bullet 1, what we did is take Eclipse Che, which is this container-based integrated development environment, and modify it to address all sorts of DevOps support for serverless computing. Now, I will also show you the Radon IDE. You will also be able to try it out if you want. But let me just give you an overview of what it contains, both for developers and operators. Now, from a developer's perspective, we also focused, as I'm showing you now, on specific policy-based and cost-based support for quality assurance. Now, in the scope of these support vectors, what we did is focus on, for example, graphical modeling of the application, decomposition of the application based on cost savings, but even defect prediction. So when you deploy your own application, you will be enabled to use prediction of the application's quality parameters, as well as verification of specific quality properties of that application as well. And also enact continuous testing of the application. And by testing, we mean stress testing, performance testing, load testing, and so on and so forth. Last but not least, in the scope of platform agnostic application and machine learning modeling and operation, the way we have designed the Radon IDE is by using Tosca as a core tenet. Now, Tosca, for those of you who don't know, is a standard for topology and orchestration specification of cloud applications. So it is a blueprinting format that is sufficiently high level for you to actually design an application in an abstract way and then concretize whatever instance of that application might be. So if you have components like data intensive processing, these components, which are generic, can be then instantiated into for example, TensorFlow, or for example, Keras, or what have you. Now, let me show you concretely from the operations perspective what we have done in the scope of the IDE as well. What we have done is offered you the ability not only to model the application itself, but also to put it in motion, to operate it in a continuous integration, continuous development, and continuous deployment pipeline, with functions which are even more advanced. So things like a function hub. So a hub that allows you to reuse components that you have developed yourself. So recommender system that also identifies these reusable units, as well as monitoring components that not only support data pipelines, but also trigger the redeployment of the pipeline when specific policies have not been met. So it raises the alarm and allows you for a retraining. Now, to give you a more concrete look on these tools and to perhaps maybe appeal you to actually try it out in action, here's a look at the graphical modeling environment. As you can see, is very basic. It's a simple box and line editing environment. Now, what you see here is based on Tosca. This is the format which is sufficiently abstract, sufficiently high level, but you also see that there's concrete nodes in the specification of the graphical modeling environment. So for example, on the left-hand side, you see a series of nodes which are very much concrete, like Amazon Lambda or a single Lambda function. So for example, create thumbnail is a single Lambda function with specific requirements, which are typical of Amazon Lambda. Now, imagine how easy it would be for you to implement this sort of application in action. I want to skip a few more because I want to show you concretely how it would work. But there's a few more tools captured in the slides. I will also leave you the slides. I will send them to Andreas at a second stage. So in case you are more interested in several of the other tools. But I want to show you, for example, in a very concrete series of business scenarios, how this would work. Now, the concrete example that I want to make you is the Via Rota smart tourism system. You might have heard of this because this comes from our friends at ATC. Andreas, you know these people, right? ATC is the Athens Technology Center.
Yeah.
I was sure that you remember these guys. This is very good guys. Very fun to work with. So Via Rota is a smart tourism system. So it includes all sorts of deployment optimization, continuous optimization, and unforeseeable workloads. So for example, in a sandbox, they had an increase of workload of 150% before the 15th of August 2 years ago. You might imagine things like these obviously happen. And this is an optimized tour plans generation system. Now, the generation system can be as simple as this, for example. So what you're seeing here now is the basic extract, transform, load data pipeline behind the application. Now, in this case, it is using basic S3 buckets. So this is still Amazon technology, but the one that I'm showing you here is an equivalent model which features Amazon Lambda. And keep in mind, the two are able in a different way to satisfy different non-functional parameters, but this second one is 175% cheaper for ADC. Now, this to me says that Radon has in fact the potential to reduce in concrete massively the cost of operation for you, the stakeholder of any application which is as complex as Via Rota, for example. And this is, keep in mind, very or reasonably small scale, because here you have what is it, like 4 to 5 functions. Imagine when you have the scale at which Twitter and YouTube and Facebook are operating. Obviously, that is where the more concrete cost savings can be manifested. And I think that's more or less enough from my part. Now, before we move concretely to questions, I want to dare you to try it out, in the sense that we have prepared a trial version of the Radon IDE, so go nuts with it. There is also documentation that you can use to actually get acquainted with it. There's all sorts of resources. In the second bullets that I'm showing you here, the Read the Docs documentation, that's a walkthrough that you yourself can use to actually test it out in action. And also, if you're not satisfied with any of it or with any parts of it, just go nuts with it. Just GitHub the shit out of it. Open issues, ask for features, comment, appreciate, whatever. So tell us a bit more about what you think. And that's it. That's actually more than enough.
Yeah, thank you very much, Damian. It was
thank you.
Interesting and live demonstration.
It was more or less.
Yeah. As always, it's a pleasure listening to your presentations.
Likewise.
Do we have any questions for Damian? I guess at some parts the presentation was a bit technical, but I think we all appreciate the value of this approach, especially after demonstrating the smart tourism application. Anyone who wishes to make any question at any level, technical or
technical, non-technical, business,
or any other question,
I can take anything.
Yeah, please feel free to ask Damian. Okay, one question for you, Damian. Is this project finished or is currently being executed?
It's not finished yet. So we have, as a matter of fact, what I've showed you is quite mature because we are almost done. So the project is going to be over in July 2021. So that's this year.
Okay. Do you plan to make some patents of your work, or how are you going to put it in the market for everybody to use?
That's a good question. So we have a plan for dissemination and exploitation beyond month 30. That also includes hosting the solution for a number of months after month 30. So it will be usable also from our end about 20 months or 24 months after we finish the project for free. But then we're also selling it to specific props and companies. We ourselves are responsible for the methodology, a part of the IDE, and the deficit prediction tool. We were planning to patent some of it. We have published it already. However, we have gotten some very good results indeed out of it. So there's 3-4 journals that you can go and take a look if you want. I can share some material if you want. Some of it is already linked here. There's a bibliography back here. There's a number of papers already that have come up. So to answer your question, it will be usable. We are planning to patent some of it and sell some of it beyond month 30, but it will be still usable for about 24 months for free.
Do you plan to have also some educational?
Yes, there will be educational material. As a matter of fact, presentations such as these and tutorials such as these are being organized as well, also in conferences and industrial venues. What we are planning to do is also to release demos of the entire application and individual components in such a way that people can really get used to. And of all of the projects that I've had the pleasure to work in, this I think is one of the most concrete. So it is very much usable. It is very much enjoyable also to work with. So I think it's actually
quite useful for developers as well.
It is also something that one uses. Yeah.
Okay, thank you very much, Damian. If you could please stop sharing your screen.
Thank you.
Thank you. I'm looking forward to having you again some other day.
A chit
Bye,
chat in
Martin.
person.
Yeah.
Yes, indeed.
Thank you.
Take care. I will stay. I might stay for a few minutes extra. I have another meeting.
Sure.
Take care.
Now, according to the program, we are a bit late, but the next speaker is my friend and colleague, Professor George Xanthou, from the University of Cyprus, who acts also as a research director of CYENS. George, are we with us?
Yeah, hi. Yes, Andrea, can you hear me?
Yes, we can hear you very well.
Okay, thanks.
So the floor is yours, George. You can share your screen. I'm not sure you're familiar with Zoom. You can
Let me, just tell me if you can see it in full screen mode.
Yes, we can see it. We can see your screen. You are
okay.
Well. We can hear you. So everything is ready. You can
start. Okay. So thank you, Andrea, for inviting me to this very interesting workshop. So I'm afraid my talk will not be as technical as the previous. I will not describe some method or something, but I will more go on to describe a center that was created. Hold on just a second. Okay. I will describe the CYENS Center that was actually, it came about through some European funding, very similar to the Destini project from the same work program, so under the widespread work program, but it's under the teaming call, not the twinning. So here under the teaming call, the idea is to help countries that are lagging behind in innovation to improve their position and become more competitive. And that they aim to do it by creating centers of excellence that have enough of a critical mass to change some of the situation in the country. And in order to make it more effective, the idea of this teaming call is that you need to team up with leading experts in your field, like institutions, European institutions that have a proven track record in your area, in order to help you to set up a center that is of the right international level and do it quickly and efficiently, but also it needs to align with the smart specialization of the country. So this was a two-stage process. In 2014, we started writing the first proposal, which went through a thorough evaluation, and we received about €500,000 to write, and about a year to write a business plan, and we submitted in 2016, and in 2017 we were selected, and we got €15 million funding from the European Union, another that much from the government of Cyprus, and about 20 million from the municipality, the universities, and other partners. So this was called the RISE project, the Research Center on Interactive Media, Smart Systems and Emerging Technologies. And the partners to these projects were the municipality of Nicosia, which is the coordinator, University College London and Max Planck Institute in Saarbrücken, who are the advanced partners. And then the three public universities of Cyprus, the University of Cyprus, CUT, and the Open University. So this was some European funding that was then going to be used in order to set up the research center. And the research center is called CYENS. It was called RISE initially, but we had some conflict with some Swedish similar centers. So it changed to CYENS. And so CYENS is focusing on interactive media and smart systems, which, it's essentially, it's ICT technologies that are to do with interaction between user and machine. You can think of many technologies in this area. We think of it in a quite wide spectrum, from mobile apps to internet applications, computer games, VR, AR, Internet of Things, and many different technologies that are gradually becoming an integral part of our daily lives and almost any sector of industry, and they can provide also a great opportunity for new research, and of course, in a horizontal way, they can help all the smart specialization areas of our country, which I'm not sure how many of you are familiar with the smart specialization. It's a number of areas that the government has selected as areas of focus for research and innovation, and here we see the list. So since we're focusing on interactive media, which is by its nature a very multifaceted problem, and our aim is not just to do basic research, but to do research with real-world applicability. So we had to bring together a multidisciplinary team that can look at the problem in a more holistic way, so that we can come up with solutions that actually are not just looking at a narrow issue that can be demonstrated in the lab to work, but it's solutions that can work in a real world by looking at the problem in it as a whole. So we brought people, already well-established professors from Cyprus, in different areas: computer science, design, psychology, multimedia, human factors, AI, and so on. All these professors have complementary expertise, but together they create synergies that can solve problems that couldn't be addressed so easily by any single department in any of our universities. So then, by having said that, I come to the fact that the vision of our center is twofold. On one hand, of course, we want to conduct excellent research. You know, we want our center to be known for its research results, publications, and etc. at the highest international level. And here we are assisted also by our international advanced experts, partners. But at the same time, equally important is to be able to go a step beyond the basic the research, which is actually a lot of the time in the society we had a complaint that the universities do good research, but they don't really have such an impact in society. So this is what we wanted to do. We wanted to go a step further. So we wanted to look more in more depth into technology transfer and knowledge transfer, not only from our center to industry and society, but also from our partner universities, which are yeah, they have a big part of the research output on the island. And not only through technology transfer, but through also a number of other activities that we'll be doing. I will mention a little bit later. We want to help the economy grow through technology and move in that direction, and also help in culture change. Okay, we were lucky when we started, because it just happened that the municipality of Nicosia was setting up their innovation strategy, and they wanted to set up this innovation ecosystem within the city, so they have a lot of funding to refurbish different buildings, to sponsor different activities. So we set up the center along, following along this municipality strategic plan, and we provide this solid scientific base onto which a whole ecosystem can grow. And we can see gradually that actually, now that we moved into the center of the city, as I will mention in a second, we are actually building around an ecosystem of innovation and technology. So, so we didn't set up the center in one of the universities, but we went directly into the center of the old city. And not only we went into the center, but our whole structure is geared towards paying a lot more attention to innovation activities. So we have a big innovation department with different sectors, like training and education for technologies towards the industry. We have a development team for taking the researchers' prototypes and taking them a step further. We have a co-working space, a big maker space and fabrication lab. We provide different services and consulting and so on. Maybe one of the most complete things that we have running right now in this innovation department is the makerspace and fabrication lab with lots of different infrastructure and services. So you can have a look at the link here and check it out. So over the last 3 years, we've been setting up the center. So we started from 0. Now we have about 85 people. We have 16 small teams, which we give them initial funding, and we encourage them and give them all the facilities to be able to grow. 10 of these are led by academics from the 3 partner universities. And some others are hired in-house. We have about an extra 50 research associates. We have the software team and the research office to help us acquire funding and manage the funding. Okay, so what about the state of the center right now? As I said, at the beginning, we used to be hosted by PwC, but lately we moved into some of our premises. So here I'm showing the area where the center is setting up, which is right next to the new town hall by the Green Line in the center of the old city. If we zoom in, we can see the first building we moved in a few months ago. We rented this space where we set up our different labs. But at the beginning of the year, one of our first buildings was completed, this STOA, which is like a 2-story building with almost 2,500 square meters, with all the facilities you need for a modern research center. And currently the second building is being restored, which is the old Agora, the old market of the city. And all this is next to the town hall with several things, as I mentioned, being restored around it for encouraging innovation and technology. Oops, sorry. I pressed End instead of... sorry, let me go back. Okay, so let me mention a little bit the research areas. As I said, we have 16 teams, and they can be roughly, they can be grouped into 3 big areas, what we call the research pillars of our center. Visual sciences, where we have the pillar leader is Destini Michail Grigoriou from CUT. Human factors pillar, human factors and design with Professor Marios Abramidis leading it. And the communications and artificial intelligence pillar with Professor Loisos Michail leading it. So if we have a quick look at the 3 areas, in the visual sciences pillar, we cover roughly most of the things that someone could consider as visual sciences, from 2D to 3D images, 3D models, 3D environments. But actually, we kind of widen it a bit to take into account also other modalities like sound and tactile. At the moment, we have 7 teams in this area, which is one of our core areas. We have 4 teams working in the imaging and computer vision area. So we have Professor Kostas Patihis working on technologies for healthcare with medical imaging and VR for healthcare. We have Alessandro Artusi, the deep camera group, which looks at smart cameras, high dynamic range, video encoding, and on-the-edge computing on cameras. We have the Smart Human Center Technologies by Professor Lanidis from CUT, looking at wearable devices and computer vision, and Dr. Melinosa Verkiou with the visual computing group that looks at areas like 3D scene reconstruction, scene understanding, segmentation, and computer vision in general. And then we have Dr. Panagiotis Haralambous, who has a team on animation and rendering. And then Despina Mikhail Grigoriou from CUT, who works on virtual reality for well-being and rehabilitation. And here is also my team that falls between graphics and VR, AR, where I look at virtual humans and augmented reality. The second pillar, which is the human factors and design, it focuses on applying knowledge about the abilities, constraints, needs, and behavior of humans to the design of tasks, services, technologies, and the environment. Essentially, we look at different aspects of human factors, perception, cognition, user-machine interaction, and how to use them and how to design applications having in mind good user experience and the effectiveness of the application. So here we have 5 teams. Museum lab of Professor Theopistis Stylianou is looking at technologies for museums, interactive technologies for museums. The Ithaca lab of Dr. Kleanthis Neokleous, he looks at arts and science, arts and technology. So how to use technology for different cultural and creative applications. Then we have EdMedia of Professor Andrei Ioannou, again from CUT, on educational experiences and gameful learning. We have Superworld of Dr. Andreas Kamilaris, who looks at pervasive computing and sustainable environments. Essentially, he's looking at different things to do with the web of things, Internet of Things, but also with having in mind how to make a more livable and sustainable environment. And finally, we have the team of Professor Marios Abramidis, who looks at the development and validation of virtual reality and mobile applications for cognitive training and clinical intervention. So Marios is a psychologist. And finally, we have the communications and AI pillar that focuses on smart sensing, intelligent communication, protocols, media and content convergence, machine learning, and planning and reasoning. Here the idea is that on one hand, we have the visual sciences and we have the human factors in order to help us to create the interactive applications. But another essential component is all the communications in the application, the networking, and of course, nowadays, the artificial intelligence that is essential to almost any application, most of the applications anyway, that we will use. So we have several teams. One is focusing on smart networks, Internet of Things, 5G networks, and quality of service. This is Professor Vasos Vasiliou. And then we have 3 more teams that work on artificial intelligence, the transparency algorithms of Jan Outeparker, which looks at ethical AI, transparency and accountability. And then we have the team of Loizos Mikhail on socially competent robotics and agent technologies, and that of Vasilis Vasiliadis that looks at reinforcement learning, deep learning, optimization, control, and manipulation systems. Okay, in order to get the center to work, we need also the infrastructure. So we have several labs in this area. We have motion capture, psychophysics equipped with all the EEG, ECG, biopack that we need. Internet of Things, we have a fairly substantial VR lab with many different headsets and eye tracking and other tracking devices. And we're setting up a robotics lab with some 4-legged robots and swarms. And of course, in order to, because machine learning is an essential part for much of what we do, we're setting up quite a large machine learning server coming soon. Now, our latest project and equipment we're setting up, which is not done yet, but I'm showing here what the idea. Here on the left, we see the motion capture lab. This is already set up. I mean, what we see at the bottom left is some results we had from before. What we see at the bottom right is the new lab that we set up a few months ago, which is much bigger and with a lot more cameras. So it has a lot of accuracy to capture several people together. But we don't want to do just motion capture. We want to combine a lot of our expertise on motion capture and on game technologies and on rendering and on animation and all that. And we want to set up a virtual production studio. And what you see on the bottom right is our first visualization of what we're ordering now, which is a small studio, mostly for research. So you see at the back, the black thing is an LED wall, which is going to be driven by Unreal game engine, while the camera is being tracked, and it's as if it's connected to this game engine. Well, it is connected to the game engine, so that you can show at the background interactive images at photorealistic quality, so that the video can be filmed directly from the LED wall with the props and the actors that you have in front. So this is the new trend in filming and in advertising and in media these days, where they're trying to cut the cost and make things much faster and much more interactive by filming directly using game engines. So we're hoping to set up a small setup within the next 3-4 months, but we're also teaming up with some other partners in Cyprus, and the overall aim is to set up something really big, something that will be a world-class virtual production studio that can film any kind of film that is needed. Okay, so that's it about the center. Let me give you just, since we're talking about smart data processing, let me give you just a couple of examples of projects that we're already running in this area. I mean, we're running a lot more projects in different areas. So the first one is about the call center quality assurance. This is funded by CEDA. And the idea is to set up an automated analysis software that we can train so that it can understand, that it can do emotion recognition and word detection, so that it can kind of moderate, follow when someone calls the call center to see if there's any issues. So this is to help CEDA improve customer satisfaction and operator performance. Up to now, they do sampling of a few calls to see if everything is okay. With this system, you'll be able to follow every call, and whenever there is an underlying issue, the system will understand the emotion and if any words have been used and highlight it to the management. So this has already been implemented in a prototype, and within the next 2-3 months, we're hoping to, or within the next maybe more than 2-3 months, we're hoping to deploy it in practice. Another project with CEDA, call center speaker verification. So the idea here is that when someone calls the call center, you can immediately from the voice understand who it is, so that you can bring the data to the operator in a faster way, but also you can verify that it is actually who he's claiming to be. Again, here we have a working prototype which we're hoping to deploy in practice soon. I'll skip this. And our final project that I want to mention is the Smart City Platform and Nicosia flagship project. So what we're doing here is that we are setting up a digital twin for the city of Nicosia, which you can think of as a parallel representation of the city, which will get live feed from the smart city infrastructure that the municipality is setting up. So we're working closely with the municipality. But at the same time, it will also have a full 3D model an interactive 3D model, which can be used for not only visualizing and displaying information, but also for mixed reality applications and mobile applications in a much more immersive way, so we can develop different things. So this, I'm not going to go into too much detail on this because Vasos Vasiliou will present it in detail in the next session. Okay, I just want to finish with some advertising that we are currently running an internship program for the summer. So if you know anyone who wants to do some exciting projects for the summer, send them our way. And we also have some PhD fellowships, quite highly paid stipends, which is currently open for people to do PhD working in science, but do their PhD at one of the local universities, either CUT or University of Cyprus or Open University. That's it. Thank you. I hope I was on time.
Thank you. Thank you very much. We're very prompt and you're on time. I see a lot of synergies between our university, our group, and CYENS or RISE, whatever you want to call it. And I'm very happy that we had the chance to have you with us to share these areas, these very challenging areas. And I'm very optimistic. I would like to extend an invitation to collaborate in the future with your group. I'm sure we will find the ways to utilize smart data processing techniques from our group to your projects or digital twins, experimentations, and the like. We have been also experimenting with digital twins, but not in the sense of a very, very realistic environment like the ones I assume you give emphasis on. We come from the area of the applied, let's say, side. So the digital twin for us is just the means to an end. And that is more to provide assistance and decision support to someone. So I think one of our possible directions of collaboration would be to utilize your experience and your expertise on the graphical part, the virtual reality, the environments, and so on, and us concentrating more to the end side of the decision support. I think it was very interesting, Yorgos, and I think you will be able to present also some applications later on.
Not me, Vasos will present.
Yeah. Okay.
Yeah. But I think absolutely, and lately, the last few months, I might say, more than before, we hired a couple of good 3D modelers. So, and with a lot of experimentation, we actually found out how to do it properly.
Yeah.
And also on the other side, the good thing is that at the center we have all the spectrum. We also have the people who work on the game engines and the rendering and whatever. So now I think we have good tools to use, and I'm sure your background would be useful for us as well for the system side of things. So yeah, I'll be more than happy to.
Good. Thank you very much, George. Is there any question from the audience? Anyone would like to address something to George or make a comment, a statement? Anything? Okay, we are a bit behind schedule, approximately 10 minutes. So I would suggest that the break of 15 minutes is to make a shorter break of 10 minutes, not 15. So we resume at 10:50. So Yorgos, please inform Vasos. 10:50 will be the next session. All right.
All right.
So, thank you.
Okay.
We will be in touch.
Bye.
Bye. George, please stop sharing your screen.
Andrea was here, so I've heard about the break, so I'm ready as well.
Okay, Vasos. All right, thanks. So we'll talk to you later. Right?
Okay.
All right, good to see you. Thanks. So we are back now to our next talk. Sorry, I had to leave because I have at the same time some obligations, some teaching obligations. So I have to switch back and forth because Zoom is the tool I'm using also for my teaching duties. So we have the pleasure to host Professor Vasos Vasiliou from the University of Cyprus, who also is a team leader in CYENS. And as George said earlier on, he will present in more details the Nicosia Digital Twin Project. Vasos, welcome, and the floor is yours.
Thank you, Andrea. Nice to be here. Thanks for the invitation. Well, you know from the previous presentation about the center and its goals and current status. What I'm going to try to give you here in the short time that we have available is a description of what we call the Nicosia flagship project. So let's see. I'm going to start with an overview of what is a flagship, what is the Nicosia project, how it relates to the city of Nicosia smart project, and then maybe more interesting to you are the use cases and ways that you may be able to interact as well with this type of a project. Just to start with a common understanding, with a definition, when we at CYENS talk about a flagship project, we consider them to be mainly R&D projects that are big in context and in effort. So it's not a typical, very directed and deterministic way of creating research. Is something that brings together a lot of activities that happen in the different groups so that they can be showcased properly. And Nicosia is one such project. The main objectives of this project is to create an interactive 3D model of Nicosia. And then we are talking about both exterior and in some cases, even interior spaces, in which this type of 3D model will be used in addition to the more traditional visualization techniques of 2D maps or maybe time series graphs, so that we can show and represent information about the city and also use the particular model for different types of mobile and mixed reality applications. Mixed reality is something that combines normal views, augmented reality, virtual reality, and any combination of those. And the 3D model is one part, and then there is the parallel digital representation of the city, i.e. the digital twin. So the city is going to be giving us information, and we will be replicating and representing in real time that data on the 3D or the other types of models that we may have. And just to make sure that we also understand what's going on with digital twins, a digital twin in the very simplest way is a virtual representation of a physical object. So you have the same information that the physical object may be giving you from sensors or cameras or things like that. And then you can actually have them in digital format. You can manipulate them. You can realize the model, or you can build models that can help you in your decision making. So we have digital data of a physical object. They're real time, and they're supposed to be used for better decision making. This is a very simple representation of, on the left hand side, a physical asset. It's a turbine, a machine for an airplane jet. And then on the right hand side, we may have the 3D model of that, and then at each particular point, or input output, or valve, or pressure sensor, we can get all that information so that models can be built and tested based on that information. Of course, for the city, it's a completely different scale. So our vision is something that at the end of the day comes in and combines all the aspects of the tradecraft that we have, which is interactive media, and the smart city issue. So we're going to have, these are, let's say, some action points for us. We started working on different of these, and then we will move on. So we will have a lot of inputs in this digital twin. The data coming from different sources regarding the structure of the city, like the land survey department, the municipality, museums, architects, and then we also have other inputs like streams from open data sources, crowdsourced data, social media information, infrastructure information about the city, utilities, all that, all these are inputs to be represented so that we can come back with solutions and models and make the life of the citizens better, and also help the municipality itself come with better and more informed decisions, let's say about planning, about extending roads or changing bike lanes and things like that. The Nicosia project will end up giving us the actual platform, which is for some will be just the tool, for some is actually the outcome of research work, how to create this platform and make it better, how to actually do a better visualization, or what kind of APIs need to be created or adapted for use by everyone. And then we have the applications that we as CYENS may be creating, or that they may come as ready-made applications provided by the city, or they can be built by anyone with access to the platform and its data. And of course, we have the research component, items of research that have to do with data management and analytics, that have to do with geospatial understanding and studies, or with context, or with recognizing humans and their interaction with the city. There's a broad spectrum of research work to be done there. So in the simplest form, we are talking about the data platform, which is not much. I mean, we have all probably built some sort of a data platform at some point. The 3D model, which is a unique opportunity for us, and of course, everything that can be created with their combination. What we are creating now is we are still collecting use cases. Those use cases will end up informing the decisions for the design of the website front, of the interaction with the users, of the maps, and any dashboards that have to do with viewing the raw data. In the near future, we will also incorporate the models and the services and the simulations on top of this, let's say, infrastructure. This is a different representation of the inputs and outputs that can be recognized in a smart city digital twin. We are talking about all possible domains. These are just some of the domains that are available: the environment, security, mobility, health. There's also education. What else is missing from here? Transportation, of course, is combined with mobility and all that. We have to say that the municipality of Nicosia, which is a CYENS partner, is one of the first, possibly the only one, the only municipality in Cyprus at this point, which has a complete smart city strategy. They have created that a couple of years ago, and then they started acting on it. And the culmination of that was a tender that they announced last year, and they actually signed the procurement of it at the beginning of March, in which they will actually build their smart city components. There are many providers in that particular tender. SIDA and Logicom, I think, are the local partners, and they're utilizing or installing a Nokia and Cisco combination of software and hardware. And at the end of the day, what's going to happen there is that the city is creating the networking infrastructure. A big part of their work is laying the fiber and other cables, setting up the Wi-Fi network and the other types of networks, so that they can actually install a number of sensors for parking, lighting, garbage, environment, and also all that, which all these sensors will provide the information into an integrated smart city platform, and then through the proper APIs, people will have the ability to pull that data and build applications, create models, and provide value. And what Nicosia will be doing is actually integrating with the integrated smart city platform of the municipality, so that we can actually combine the raw data that comes from the city with other data coming from open APIs and proprietary data coming from different sources, and other types of metadata, let's say, other information that can be used to create more detailed applications, to create process data, models, and services. Some of them will be for our use and to support our research, and some of these applications will be for everyone to use. We are using the 5-ware concept, at least this is what we have started with. It's not a very complex model. It has the same structure. You get data from the bottom, So you have southbound APIs, you have your databases and your, let's say, your engine, your processing in the middle, and then you provide northbound APIs to those wanting to use the platform. So what we have at this point is a data platform which is based on microservices and the fireware concept. It already has a set of input and output APIs and a number of data sources in the system. And now we are trying to create sample or, let's say, proof of concept applications on top of that, while the 3D model is built and being upgraded, in the sense that we have a model that is based on older data, and now we have in our disposal more recent data. And just to give you an idea on types of applications, which are actually work in progress by some of our groups, and some of them are done at the Cyprus University of Technology or the University of Cyprus. One such application is for crowdsourced obstacle reporting. So you're in the city, you see something that is broken or missing or wrong, you send either the location or and the description or a photograph, and then it gets processed and then gets in the pipeline to be addressed. The same team is also now working on automatic recognition of these, either from the images that are sent, that are crowdsourced, or by someone who actually navigates the city with a camera, with an on-body camera, and recognizes this in real time. An extension of this would be recognizing obstacles and alerting blind people so that they can avoid them. A different application is about visualizing quality of living metrics, quality of life metrics or indices. And then we see here, based on different issues, which areas of the city have more parking places per inhabitant, let's say, or have more cultural places, or are home to more, let's say, entertainment establishments, bars and restaurants. And then you can start building on a combination of these, in addition to other information like traffic, pollution, noise, and everything else. And then you can recognize if you have represented or underdeveloped or areas in your city which have actually a problem, and maybe that's why they are being ghettoed or have diminished values and all that stuff. This is one very high-level representation of the digital model we have now. It's being progressively being upgraded with more details about the roofs and the types of buildings and the look of the buildings, the texture of the buildings. I know that our time is ending, so I just want to acknowledge that this is a work done by a lot of people. At this point, there are 4 of us kind of leading the project, 2 from the data and platform side and 2 from the 3D model side. And there are teams of software developers, 3D graphics, and other researchers working on this. Thank you very much for your attention. I'm open to answer your questions.
Thank you very much, Vassos, for the very interesting presentation. Is there any question from the audience? Anything you'd like to ask?
maybe I should point out that once we have that in a working order, let's say, once we're ready to accept external users, we'll open it, and interested researchers can actually request access, and we can work with them to bring more interesting applications into our everyday life.
Mm-hmm. I have a question, Vasos. How do you reconstruct the images of the buildings? Do you use, for example, drones or some other technique?
There are different techniques, yes. There is information about the buildings coming from the Land Survey Department. There is also information that our researchers have acquired through normal camera scanning, like photogrammetry, to aid photogrammetry, and drones have been shown to provide very good information. One of our groups has used it to recreate the monastery of Agios Neophytos, the Eglistra of Agios Neophytos, with very interesting results. And I think now they're going to replicate that process in the city of Nicosia. There is, last time I heard, they were trying to navigate through some let's say, issues with flying drones so close to the green line. So yeah, but yes, you can use 360 cameras or specialized camera rigs. Maybe the 360 cameras that Google uses are not as effective because they are more wide angle, so they distort the information. But I know of, let's say, a car with 8 cameras on top, specialized equipment and stuff that can actually do that. And then drones, that's for sure, yes.
And also, I see a lot of synergies and common ground with some of the techniques that our colleagues here use for digital cultural heritage monuments. So I don't know if you have any sort of collaboration with Marinos Ioannidis or his group.
We obviously know about Marinos. I don't think there was anything specific initiated. Obviously, we have a lot of colleagues from CUT, from multimedia department, actually. I'm sure that, as I said, when we are ready to offer this for more wider use, we can again get in touch with you and Marinos and anybody else who.
Excellent. Good.
Yeah.
Good.
Sure.
So thank you again, Vasos. If there is anything from the audience, one last round, anything would like to address to Vasos? Anyone?
And if you have ideas, or if you're working on existing applications and you think, okay, these people at CYENS could use this or could add this to the portfolio, please let us know, either me personally or through Dr. Andreu. We'd be happy to actually work and collaborate with new people.
Yes, exactly. Yes.
Thanks.
Okay. Thank you very much, Vasos. We'll talk to you soon. So now, if you can please stop sharing your screen. All right, thanks. Now we are moving forward according to our program. We have 2, let's say, applications or case studies from 2 groups of students under my supervision. The first one is the digital twin I mentioned during my presentation for a smart hospital management, let's say, application, and will be presented by 4th-year students in our department, by Alexandros Christodoulou and Vasilis Andreou. And then a continuation or a directly linked work with that. It's another application of smart digital twins. It's a a smart health record, which will be presented by Stelios Mapouras and Evangelos Georgiou. So I don't want to interrupt between the two groups. So guys, once the first group finishes, please, as we discussed, pass the word to the other team by demonstrating how the smart hospital environment is linked to the digital twin smart health record. Okay, so Alexandros, you have the floor. You can share your screen so that everybody hears
you. Can you see my screen?
Yes, perfect.
So, hello from me. I'm Alexandros Christodoulou, and with my teammate and colleague Andreou Vasilis, we are undergraduate students of computer engineering and informatics at Cyprus University of Technology. And today I'm going to present our system, which is a digital twin for smart hospital management.
Hello, my name is Vasilis, and let's see for a moment the contents of the presentation. First, we have the targets of the system. Then we have the goal of our system. After, we have the hospital functionality. Then we will see a little the database that we use for our system. We will see the system overview, the next step of our system. Then we will see a small video demo, and finally, then conclusion.
First, we want to start with the targets. So what we want to do is to create a digital twin of a hospital. And with that, I mean that we have to create a realistic visual environment of the hospital. And that realistic visual environment will have a database on the backend. So some information of the hospital, such as equipment, let's say serums, beds, patients that take care at the time. For example, we have also defibrillators and some other equipment, and some information about the rooms that we have inside the hospital. So from our database, we want to retrieve all this information and visualize it in an environment of the hospital that we created. All of what I mentioned until now in our targets come out to make a main target. That target is to offer decision support to the management of the hospital. That is very significant for him. So to continue, we want to see the goal of our system. What we want as a goal is to provide intelligent health services that will give the hospital manager some different opportunities. First, we want him to have access to all the hospital data at any time. What I mean is that we do not want him to have many papers in front of him, try to sum up numbers of equipments and other things. We want him to have everything inside an environment, so it will be helpful for him to find out what's happening at any time inside the hospital. Also, to have a clear view of the hospital, and what I mean is about the setup, how the hospital is set up on different scenarios, or at the moment, how the hospital is set up. Another thing that come out from these two that I mentioned is that we want him to have the opportunity to create and apply strategic plans without any risk. And this is a kind of simulation. So we want him to think, to find out, and make some different emergency scenarios inside our environment, so we will be ready in future situations. So many problems will be reduced due to this. Like if we have a system like this, for example, in the COVID purpose, for sure some problems may not be appeared. To continue, the functionality of the hospital contains some different things that help the manager to view or modify the hospital environment and its information. As we mentioned, we have a 3D view of the hospital, including a walkthrough. We give the chance for a top view of the hospital which also will be the modified view. And from there, you can see the setup of the hospital as we said. We have the visualization of every room's data, like the equipment that I mentioned, the defibrillators, beds, and etc., and the patients that are inside the hospital. In addition, we have some patients' information that we visualize in the system, but there are some main information, not everything. If we want to see more information about the patient, we have the chance with a button that links us to the other digital twin that Mr. Andreu referred to before we started. Also, we can modify the hospital environment. We can create new scenes depending on different emergency scenarios, like COVID, as I said before. In emergencies, we give the chance to add new equipment to any room or to create a new room inside the hospital environment. In addition, we have some reports about the hospital, but these reports differ depending on the scenario that we did, because they're about equipment, patients, and some other things that we will see later in the presentation. And we have some privileges of who has access to a room depending on the situation. And these privileges can be modified depending also on what scenario we are.
So now we will say a few words about the information we store in our system. First, we store some equipment such as medicine beds, respirators, serums, defibrillators, and others. We also store some patient information, such as first name, last name, the reason for care, then doctor who is responsible for him, then date theater and when it will come out. We still have the information of each room, such as what name it is, what equipment it has, and what it should have, based on the model of the room, the equipment template. Continue, Alex. We will now look at the system overview. First, we have the login screen. Here, as we see, for connect to our system, the controller needs to enter his email and his password. The important thing in this slide is to see that the user can choose whichever version he wants. It was one of the hardest things we had to do. Whichever version he wished to enter, these are loaded on him information, and when something changes, it will be stored in that and only. And then, after choosing the version, the user can log in.
Now, to continue, as the admin will be logged in the hospital, the first thing that you will see is the 3D view. So, as you can see in the picture, in that 3D view, we don't give him the chance to modify something. As you can see in the picture, most of the buttons are disabled, except the switch view or the logout. In this view, we want him just to have the chance to make a walkthrough in the hospital to see how the setup is at the moment, or to see some information about the patients that are taking care at that specific version. Now, as I said, we have some patients' information inside our environment. As we enter a room, for example, the admin enters the pathology room, and he sees that patient on the bed. He can click on that patient, and as we see in the right picture, some main information appear for him to see who is the patient, who doctor taking care of him, for what purpose is in the hospital, what date he have been admitted in the hospital, what date will be discharged, and what his room is. The most important thing that we have to see in that picture is the button with the patient personal record. That button links our system to the smart health record system, which is based on digital twins that we represented after that system. Now, if we press the switch view on our menu, we will see the top view of the hospital, like in the picture. As you can see in our top view, we can see obviously the occupancy of any room. If you see, we have some models up to some beds that show the occupancy that the room has. And also, we can see the labels of the rooms that act like buttons who can show us more information about the given room. As you can see also, the menu buttons are now enabled, and in that view, we can modify the environment of the hospital, and we can see more information about the hospital. As we continue, I want to mention the room labels. When we press on a room label, like I said, it acts like a button. So the window on the right appears that show how many patients are inside and what type of equipment we have and what quantity of each equipment does the room contain at the moment. Additionally, we give the chance to the hospital manager to add equipment to any room. Let's say that in the right picture we had 2 medicine beds, 2 serums, 2 bedside tables, and 2 chairs. We have a button in our menu which is the add equipment button. If we press on this, as we can see in the left picture, that window will appear. We can click on the medicine bed, for example, and it will be added to our hospital. When it will be added to our hospital, it's not coming from nowhere, it's coming from the storage that we have in our database and have some specific number of equipment inside. Now, if we want to drag the medicine bed inside any given room, and as we can see, if we click on the label again, the information inside the hospital changes about this room, changes real time, so the manager knows what exactly happened when he did the modification. As we continue, I want to give attention to the modify rooms equipment, to how we can modify a room. For example, if we click on a bed, we have the chance to rotate it either right or left, which is very important if you want to rearrange the setup of a room. And also, we give the chance to remove any given equipment inside the room. As you can see here, like the add equipment, if you select anything inside the room and delete it, it goes in the storage rather than add equipment that is coming off the storage. So we give the chance to the manager to delete any equipment from a room, and also the information about the room changes real time, as you can see in the right picture. Now, one of the main features of our system, and I think maybe is the most important thing, is that we can create and save scenes. What I mean by this, we have a button in our menu that it's the create new scene. If we press on this, the above window appears, and we can give a suitable name to a scene that we want to create. For example, COVID emergency. We can create the scene, and as soon as we create the scene, a sample of a scene is being loaded for the manager. So now he can make any changes he wants about that specific scenario, save the changes, and as Vasilis said in the beginning of the system overview, it can be loaded in the login screen, so he can log in and see how that scenario will affect the environment of the hospital. To continue, we have some reports about the hospital. As we can see here, we have some reports about how many rooms we have, the equipment that we have in the hospital and in the storage, the reasons that our patients take care at the moment, how many patients we have, when they have been admitted, when they will be discharged, and also how many beds we have in each room in total, how much of these are in use, and how many are free. So now we can have next steps that we didn't finish until now, and will be completed in the remaining days until our deadline of the thesis. The first thing is the reports. We want to make them absolutely right, because it's something very important for a manager to have right reports in front of him, so he knows exactly what is happening inside the hospital. Some arrows that will show the flow inside the hospital and the privileges that the hospital have in some specific areas. And we want also to give the chance of converting rooms to any other room depending on the scenario. I mean that if we have a pathology room and it's not being used, and we have, for example, many COVID patients, we can convert that given room to a COVID room. So we give them chance to more patients to be inside the hospital without any problems. And as we continue, we will go to the system video demo now. Here, I will show you how our system looks like. As we can see here, we are going in for a walkthrough inside the hospital. We enter a room here to see some equipment. This is a pathology room. We see some beds and serums. Here we can enter a COVID room where we can see some ventilators, serums, oxygens. And here is a patient where we can see some main information, and also the patient personal record button that I mentioned before, which links us to the system of the other digital twin. Now, we are going to go through in the hospital because I want to show you some more equipment that we have, and it's very important for a hospital. Like the oxygen we see before, the cardiographs we have here. Also, we have the ventilators, the serums that I mentioned before, the beds. We can see some stuff for intensive care. We can see some defibrillators here, some extra serums, and as you can see, we have also some therapy tables that help doctors for any emergency. Okay, as we go to the switch view, I want to mention that in our hospital we have some different types of rooms, like first aid also, and some doctor offices and operation rooms. Now, we have switched you to the top view that we saw before, and now I'm going to make some changes inside the room to see how it will be set up in a given scenario, for example. As you can see, we are deleting equipment one by one. This we want to make it better so he can remove multiple things at one time, and it will be one of our goals in our remaining days. Now we will remove all the equipment from the hospital, from the particular room, sorry, and we will add some different equipment just to show you how this works. For example, we add a Meddesign bed. As you can see, the Meddesign bed is being blue when it's selected. In addition, we will add a serum. Inside that room, we will also add a ventilator. And here we can see the rotation that we have for the equipment, because we want him to be in the right side. And also the oxygen we will add here. Further from that, we have the chance to create a new room, as I mentioned in the beginning of my presentation. As you can see here, we can remove some stuff inside the waiting room. So that will give us a chance to clear the place to create a new room inside the hospital in case of an emergency. For example, we have a COVID emergency. As you can see here, we can choose some walls we have as a part of equipment, which are movable. So we can put them on the right place inside the hospital. We can also rotate a wall to be on the right place. And we will add now, as we finish with the walls, we will add some equipment inside the hospital. Here we will add a medicine bed, as you can see here, some serums that will be next. And we will go for a walkthrough when I will finish with that additions inside the new room that I did. As you can see, we are finished with the new room. And now we are going to switch the view to have a walkthrough to see if everything is okay. Now, as you can see, the new room is on our right, and we can see that everything is okay. If we go to the other room that we changed the equipment, we can see also that the equipment was added successful, and we set it up with what we wanted to do. Okay, that was our demo for now. And now I want to mention an important thing that we want to add. Here is some arrows that shows the flow inside the hospital. The green show that public can insert in that area, but the red shows that they can only exit from there and not insert inside there. And as I know, Mr. Andreu want to add an example on that particular slide, if he hears me.
Yes. The goal of this, let's say, traffic simulation is to be able to simulate how people enter or leave a certain room, which, for example, treats COVID patients. So our intention is to give a tool of simulation to the management so that the new rooms that are inserted in the top view or rooms that are modified, for example, the pathology room becomes a COVID room. We need a way to assess whether entering or exiting certain areas of the hospital is satisfy some health measures and some health precautions that the hospital has put in place. So in this case, the different uses of the spaces in the hospital will be accompanied by a simulation of the flow of patients or of visitors or of the staff, indicating free entrance with green arrows and prohibited entrance, prohibited flow with red arrows. So in this case, the management of the hospital may draw up some plans regarding the use of the space, the use or the alteration of the use of a certain part of the hospital so that the spread of some disease is minimized or eliminated. Okay. So, Alexandros, you can resume.
Yes. Now, I want to finish the presentation with the conclusions. As I said, we want to create a digital twin of the hospital. As far as we did until now, we have some main features inside our hospital. And we created also a visual environment of the hospital that gives the chance to the manager to see and set up the hospital for any given scenario that has to his mind. So we want him to create and apply strategic plans without any risk, as we said, and that will reduce problems for decision making in future situations. As our main target was, is to offer decision support to the management of the hospital, which is something very important, as we mentioned in the beginning of the presentation. And all of these conclusions come out to make a big conclusion, that this work is a proof of a concept. And what I mean by this is that the theory and idea we have, we can see that it has a practical potential with what we showed you in that presentation. Thank you very much for your attention. If you have any questions, here are our emails or something. And now,
thank you. If there is any question from the audience, please free to make it. Now the second team will demonstrate the digital twin for the smart health record. And as Alexandros mentioned earlier, the two digital twins are linked together, basically from the hospital management system that Alexandros just demonstrated. We have the ability to click on a certain bed, and then apart from the summarized information, we can click on a dedicated button, and then this will trigger the application of the smart health record digital twin, which will be presented now. So if there is any question for the guys now, otherwise we can proceed to the next presentation. Okay, so Evangelos and Stelios.
Good morning.
Hello, Evangelos. Hello, Stelios. So you can share your screen, guys, and start your presentation. Wait a moment. Okay, it's just a congratulations. All right. The floor is yours.
Hello, my name is Stelios Makouras, and with my colleague Evangelos Georgiou, under our thesis project, we created a digital twin called Smart Health Record based on digital twins. We are studying computer engineering and informatics at the Cyprus University of Technology, and our supervisor for this project is Dr. Andreas Andreou. For the contents of our presentation, we will start by introducing our main target on this project. Then we will explain some essential information about what is a digital twin and how it is applied in healthcare. Then we are going to explain our goals for this project with the tools that we use to accomplish them. Later, we will showcase our web application and the digital twin that we created and demonstrate the video to have a clear view of our applications. So our target is to create a smart digital twin that is going to have application in the Department of Health. Specifically, our main goal is to help doctors. We will store and visualize health record data of the patients, which is something that is going to have many benefits for the doctors that we will see later. We will give to the doctor the opportunity to have access to the health record of the patient through a 3D environment, where he will be able to manipulate the data by having the ability to access the information and either add more information, edit or delete the existing data of a health record. For this project, my responsibility was to create the digital twin with all the functionality that the user can see. My colleague Evangelos is responsible for the functionality that the user cannot see, managing our database and the web application. So what is a digital twin in general? A digital twin uses simple words. It is the digital representation of a physical object or a system, that this can be anything that has functionality, for example, machines in the industry, cars, or in our case, patients' health file. Digital twinning is an upcoming technology that is growing rapidly because of the great benefits that this technology can offer. Digital twins can boost productivity because if we combine a digital twin with smart data processing, we can analyze and visualize large data sets within a short period of time. Automatically, this reduces the production risk. For example, for a machine in the industry, companies now can test the new functionality before launching it to the real machine in order to see how a machine reacts or what are the flaws of this upgrade. At the same time, it lowers the maintenance cost because we can visualize the condition of a machine using sensors or data from the machine. So we can fix the things that are going to break before ever breaking. These concepts can apply the same in healthcare. The first point I would like to mention is the outcome prediction. Outcome prediction means that we can get the expected results from a specific input, like we said with the machine before. For a medical apply, we can see that we can give a medicine to a patient and we can get the expected side effects that will take place based on his medical health, depending on the diseases or disorders that this patient has or the surgeries that this patient has made. Thus, this leads us to the second point, therapy and decision support. Using the outcome prediction, the digital twin can help the doctor to decide which medication to suggest to the patient according to the data that is being visualized on the screen. For example, like as I said before, the side effects of a medicine or the medical history of a patient. If a medicine will cause any side effects on the patient, then digital twin has the capability to warn the doctor about the side effects, and then the doctor is responsible to decide if he wants to take the risk to give the medicine to the patient or not. Lastly, a digital twin can offer chronic disease management. The application can keep track of the patient's symptoms and decide whether the chronic disease is doing well or is getting worse. So it will inform the patient when he has to go to the doctor. Furthermore, a digital twin can remind the patient to take his medicine or plan the next visit to the doctor for him.
Our goals are to create an effective smart health record where we give the opportunity to the doctor to treat the patient with a more efficient way, to give a patient a better diagnosis and therapy. The digital twin, it will be accessible through many devices like website, web app, Windows application, and Android devices. We want to give to the doctors a faster and easier way to search and find the patient's data at any time without looking in their files. Finally, we will offer statistics about diseases and the patients. The tools that we use to build the digital twin is the following. Unity is a tool where we use to create the digital twin. Unity is a platform that mainly used on 2D or 3D games, but it has a lot of flexibility, so we found that it was the most suitable tool for our case. For the 3D editing, because we didn't have any experience before this project, we found some tools difficult to use for some tasks. That's why we used three types of 3D designing tools. We used 3D Max to break the 3D meshes apart. We used Vectory to break apart the connected 3D meshes in order to have more details on the model, and Blender to cut our meshes precisely. Laravel is a PHP framework which follows the MVC architecture, model view controller. The model is used when we want to retrieve information from the database. The view is on the front end, what the user can see, in our case, the health record of the patient. And the controller is where we write all the functions when we want to add, edit, delete, or send data to the view. With Laravel, we also created the APIs where we use later on to get the data with the C# for the Unity. The C# is a programming language for the Unity backend. With Unity, most of the functionality we have on Digital Twin is written in C# scripts, which are communicating with our Unity project. We used in GitHub to save our code. Now for the electronic health record web application. In the website, when a doctor's login, we will display him a table with all the patients. He can search a patient based on his ID, name, surname, telephone, email, and date of birth. By pressing the button at the right, we relocate the doctor to the patient health record. The health record is divided by 5 sections, as you can see on the right. Based on the information I found after my research, I tried to add all the common informations together. By clicking in the patient's information, the doctor will be able to see the personal information, the contact information, and the family history. For the family history, we keep a record for the disease name, the year and the age that the family member was diagnosed, and description about the problem, in which family side is the one with the disease, and some extra notes for the doctor in case they want something to see later. Another section is the diet, habits, and immunization informations, where we keep the name and the date of each one separately. The next section is illness information, where it's divided in diseases history, allergies history, and disorder history. For the diseases history, we have the ICD codes, the symptoms, the date, the doctor who's seen the patient, and the diagnosis. For the allergies, we keep a record about the name of the allergy and description and the date. For the disorder history, we have again the ICD codes and description about the problem and the date. And we added all these three informations together, so when a doctor is going to give his patient the right treatment, he can find all the information together. The ICD-10 codes I mentioned earlier is the foundation for the identification of health trends and statistics globally, and the international standard for reporting diseases. It's a diagnostic classification standard for all clinical and research purposes. ICD defines the universe of diseases, disorders, injuries, and other related health conditions. In simple words, ICD codes are used by doctors to describe a problem in shortcut. For example, as we can see at the right, for the certain infectious and parasitic disease, based on the infection that the patient has or the parasitic disease, the ICD code can be from the range A00 to B99. The next section is the doctor appointment, tests, and the medications. For the doctor appointments, we have the reason of visit, the doctor name and specialty, some description and the date. For the test record, we save the name, the reason of the test, where it took place, the date, and some comments for the doctor in case the results were something worried or they saw something strange in the results. For the medications, we have the name of the medication, the doctor who gave him the prescription, the dosage, the started and finished date, instructions for the medicine, and some side effects. For the medications, we have a validation in case the doctor wants to give a medicine to the patient, but the patient can't take it because of a disease he has. For example, the patient Felipa has embedding brain abscess, and giving her, for example, a Nurofen, it will cause her some side effects. The doctor can change the medicine, or he can proceed to ignore the warning if he believes that the medicine will do good here. And the next section is for the obstetrics. Here we keep a record for the doctor name, the type of the pregnancy. For example, if it's a single pregnancy or multiple pregnancy, we save the date of the child and their names and any complications that may occur. The last section is for the surgeries. Here we keep a record for the surgery name, then the surgeon, the assistants, any complication that may occur, and the procedures that the surgeon followed. The web application is not a common website. It has been built to support the health record of the patient and exchange information with a digital twin. All these data are saved in the database, and we created APIs to access the data faster within the digital twin. Now my colleague will showcase you the digital twin.
These are the main models of our digital twin. we can see the full body model, the muscles model, the organs model, and the skeleton model. On the muscles model, we can see the muscular system. On the organ model, we have the cardiovascular, respiratory, endocrine, urinary, and reproductive systems for our patients. And lastly, on the skeleton model, we can see the skeletal system. For me, because I had no previous 3D experience, this was probably the most difficult part for now, because we had to modify the 3D models according to our project needs. For example, the organs model is a modified skeleton that we had to put the organs one by one in him. All the models except the full body model have colliders on them to accomplish the text on cover feature that we will see later. All the models can be rotated by holding the right click of the mouse and can be zoomed in to see more details on them. These are the female models of our system that the same functionality applies on them. The first thing that the doctor sees when he launches our digital twin is our starting menu. The first Phantom patients, by clicking on it, we are going to the patient screen. The second button opens up the settings window, and the third button exits the application. Now for the settings menu, if it's the first time that the doctor runs the application on his computer, the system initializes some default settings by itself. The resolutions are set based on the resolutions that the doctor has on his machine, and the preset default resolution is the one he's currently using on his computer. Then we can see the graphics quality drop-down, which is responsible to change the quality of the graphics according to how capable his machine is. After that, we can see a toggle button to play the app in full screen, which works in real time. For example, if it is enabled, the application goes to full screen immediately. At the bottom of the screen, as we can see some general tips that we want our user to know while using the application so as to achieve the best possible user experience. Also, something worth mentioning is that after the first time the application is used on the same machine and change any setting, the application saves the user preferences locally on his machine. So the next time the application opens, the settings will be kept and loaded automatically. In this slide, we can see the patient selection scene. In this scene, the doctor can see a grid of the patients that are coming directly from the database dynamically, and the icons are loaded based on the gender field of the patient from the database. If a new patient on the web application is added, this patient will be shown here, and the deleted patient will no longer exist on this screen. So when a patient is selected, the models in the next scene are being loaded according to the gender of the patient. After selecting a patient, the doctor will be able to see this scene. This scene is the main scene of our digital twin. We can see the patient's full body model, a file on the left that opens up the medication that can provide to the digital twin, the digital patient, in order to see if there are any side effects, and two buttons with an icon of plus, left and right, that open up their left and side menus. The left side navigation menu represents the patient's health file. It is structured by type, and each type has records in it: diseases, disorders, allergies, medications, and surgeries. By clicking on a type, a window opens down, including the records that is in that type of field. All the information is coming again from the database and loaded when the doctor selects a patient. By selecting a record from a window, a pop-up window appears with more information about the record that was clicked. The left menu opens up when the left button that we saw earlier was clicked and opens up with a slide animation. The right side navigation menu, we can call it like the settings for our models. The window slides the same way like the left menu. And on the menu, first of all, we can see some checkboxes that by choosing one, the appropriate models appear on the screen. For example, if the skeleton checkbox is selected, the skeleton model will appear on the screen. Next, we can see the text on hover checkbox that disables and enables text on hover, that we will see in a little bit. Text on hover is a feature that by hovering the mouse on a body part in any model excluding the full body models, a small text appears with the name of the part that the doctor hovered on. Then you can see the expand organs checkbox, which is interactable only if the organs model is selected. The expand models checkbox shows all the models at the same time on the screen. The reset button is responsible to reset the position and the rotation of a model. So if the doctor rotated the model a little too much, he can easily bring the model back to the default position by using this button. Here we can see the functionality of the checkbox expand organs. The organs of the model pop out, and you can see the text above them indicating the name of the body part. This can help the doctor to have a closer view on the patient's organs. In this slide, we can see the functionality of the expand models checkbox. All the models of the patient appear on the screen, so the doctor will have a clear view of all the patient's problems at the same time. This can help him to make a better diagnosis, because if he just received information from a paper, when he changes slide, he would forget what he saw on the last slide. So here he has all the information appearing on the screen together, so it is much more efficient for the doctor to get all the information he needs in order to make a correct diagnosis. We saw these red information buttons before, but we did not talk about them yet. Those eyes represent a problem on the body part they are indicating. These problems are saved in the database, and when the model loads, the system automatically loads all the appropriate eyes with the problem, and the problematic body parts become red. If the doctor clicks on an eye, the window we see on the screen appears, explaining information about the problem. At the top of the window, we can see the title of the patient of the problem, followed by its ICD code and the description. Also, we have a link button called See More on the window that goes to the Gov application, showing further information about the patient's problem. This functionality will be shown later in the demo we prepared. As we saw before, there is a bug on the left that by clicking on it, it opens a window that has some medicines in it. A feature that on hover will show the medicine's name will be added later. The doctor can drag and drop a medicine on the patient's model, and if there are any conflict with a disease that the patient has, the information button that represents this disease will blink until the doctor notices. This can prevent the doctor from doing any mistakes in his medicine suggestion, and it is also something that we will see in the demonstration.
Stelios, maybe you can explain, you or Evangelos, what we are looking in the demo?
Yes, this is the website. This is the whole the health record of a patient. We are adding some immunizations right now. Here you can see the informations. We are now in the illness section, and we are adding a disease. Here in the drop down is the ICD codes I explained before.
And the ICD-10 codes, Evangelos, is quite important because the system is compatible with any other practice that follows the same standard. So it's not tied up to specific, let's say, diagnoses that are not compatible with other systems.
Exactly. Now we are going to add a medication and we will see that validation I explained before. Here is the warning. He can choose to close the warning or proceed to or continue, and the medication will add if he press the yes. And now we will see all this information in the digital twin.
So what we are looking here is the settings of the screen. Stelios?
Yep, this is the setting of the screen. This is the grid of the patients that we explained before. It loads from the database. Here we selected a patient and we can see the models. This is the skeleton.
So the red part indicates some record on some transaction on the medical record, right?
Yep, the red body parts are indicating a problematic body part. And we can see the eye that by clicking on it, we can see the information of the problem. Here is the organs model for the male patient. We can see the detection cover for the urinary system. We can see very little details. Here is the information I explained before. And this is the show more button that goes to the web application in order to see more further details. This is the expand organs that the doctor can see the organs more closely. This is the muscle model where we can see the muscles of the patient. We can see any problems on the muscles that appear. This is the expand model that can help the doctor with the diagnosis. He can see all the problems of the patient, the screen at the same time. And this is the left navigation window. Instead of seeing the information on the model, we can see it also from here. So this is a health medical record in a window that is coming from our database. And this is the medicines. If any medicine causes conflict, this blink will happen to notify the doctor. The medicines part is not completely done yet. So we go to select a female patient. The The digital twin with the females have the same functionality, but it loads different models. This is the urinary system of the female. And this is the female model. You can see some details on her. As we can see, she has a problem on her back, on the muscles. And that was our demo.
That was our demo. And to sum up, with this marker record, we want to give to the doctors a better tool to work with, giving them the opportunity to store and update patients' data, an easier and faster way to see the patient's health record, to minimize the error factor, as we explained before with the medications, and finally to provide the doctors an easier way to treat the patient. Thank you for your time. If you have any questions, feel free to ask.
Thank you, Angelos and Stelios. Just to remind you all that this is currently work in progress. It's not finished yet. It has nearly 1 month to work on. So some of this functionality is not completed yet, as the guys mentioned before. And also, I would like to emphasize the fact that this work, as well as the work of Alexandros and Vasilis on the digital twin for smart hospital management, are proof of concepts, are demos, are pilots that basically suggest how digital twins can become smarter, can become interactive, can assist in decision-making and support different contexts and different professionals in doing their jobs better. Having said that, I would like to ask the audience if there is any question, any comment. We are nearly done, so we have time for anyone to share any ideas, any statements he or she would like to make. Please feel free to speak. Panagiotis, you have open microphone. You need to say something. No?
Hello, Professor Andreas. No, it's fine. Thank you.
Okay. I thought you were going to ask something.
No.
All right. So anything else from the audience? No? Okay. So I think we can wrap up things. I think the first day went very well. We had interesting presentations from a variety of speakers, from our friends at YATS, our colleagues at the University of Cyprus, the Science Center of Excellence, and of course the two quite interesting applications by our undergraduate students. We have also an interesting day tomorrow with presentations from the Cyprus Telecommunication Authority, speaking about the introduction to 5G technology and to smart cities. We also going to have a colleague of ours from Sapienza introducing the Data Cloud Horizon project. Also, we will be having one of our colleagues here at the department, Professor Michalis Michailidis, talking about their project, STEAM, Sea Traffic Management in the Eastern Mediterranean. And also Irodotos Irodotou, who's going to speak about data-driven applications for optimized sea traffic management. This is an application in the context of the STEAM project. And the day will close with two other case studies, two other undergraduate theses from two more guys of our group, Thomas and Vassos. They are going to present topics on automated machine learning. I think Damian from YATS talked briefly about AutoML. And also Vassos will present an overall context of smart data in IoT environments and possible applications. All this is a quick summary of the program of day 2. So having said that, I would like to thank you all for your presence. I think the topics, especially the applications, are quite interesting. So feel free to suggest the school to other colleagues, friends of yours, and we will be happy to welcome you again tomorrow on our second day. If anyone, last minute, if anyone wishes to say something or add or ask, okay. Thank you all. See you tomorrow. Have a nice day.
Bye, everyone.
Bye. Bye-bye.